Welcome to my channel. Here today we will discuss about the class 10 general maths, and the topic is Euclid's division lemma. So before going to the lemma, we have to know two terms. Number one, what is lemma, and number two, what is algorithm. So it's very simple. It's also given in the book. Lemma means a proven statement, means you no need to prove. A proven statement used for proving another. So to prove something, if we apply a statement that is already proved, we no need to prove, that is called lemma. So lemma means a proven statement which is used to prove something else. And then comes algorithm. Algorithm means steps of process. Steps of process to find a particular type of sum. Suppose Euclid's division algorithm. So Euclid's division algorithm means you will apply the lemma in every step. It may take 3 steps, 4 steps, 5 steps, and all together, all the steps together are called Euclid's division algorithm. That is the algorithm. So come to the point, Euclid's division lemma. So before going to the lemma, let's recall our previous knowledge that we have already got, that dividend equal to divisor into quotient plus remainder. That is our simple division algorithm. Means if we divide a number by another number, we will get quotient as well as remainder. So the relation is dividend equal to divisor into quotient plus remainder. So here also same, there is a link. What is the link? Here we are not telling about the dividend, divisor, quotient and remainder. What we are taking? We are taking a number A as dividend and another number B, suppose as divisor. If we divide, we will get a quotient. So here we are not mentioning quotient, we are writing Q, and remainder is R. So if we put into the division algorithm, what it will become? Dividend equal to divisor into quotient plus remainder. Yes or no? So this is the Euclid's division lemma. For any two integers a and b, there exist two unique integers. Some of the words are there, very important. Two unique integers. It will be always same for those two numbers, q and r, such that a equal to bq plus r. If you forget this, what you do? You just recall the division algorithm symbol. And here the most important part is the conditions given. What will be the condition? That 0 less than equal to r less than b. Means what? As usual, if we divide a number, the remainder may become 0 or may not. But the value of the remainder will be always less than the divisor. Always. Because if it is equal to also divisor, we can again divide it. So here also same. The remainder or the r will be 0 or greater than 0, but always less than b. Okay, this is our Euclid's division lemma. So here 2 or 3 things you have to note. Number 1, can quotient be 0? Yes, quotient may be 0 in some of the cases. What is the cases? When a is less than b. If a is less than b and we divide a by b, you see an example I have taken. I have taken a as 6, b as 7. Can you divide 6 by 7 in the Euclid's division lemma? Yes. How? 6 equal to 7 into 0 plus 6. You can write. So in those cases, you will get the quotient is 0. Now we will discuss how to find the HCF of 2 or 3 numbers by applying Euclid's division algorithm. So before doing this, what you have to do? You have to remember or recall the Euclid's division lemma. It was a equal to bq plus r, where r 0 or more than 0 but less than B. So we have to first think which one is a greater number, because generally what we do, we divide a greater number by a smaller number. So here you are writing, since 396 greater than 231, so applying Euclid's division algorithm. So here you remember a point, if we don't write the algorithm and if we write lemma, then what will happen, after every step we have to write by applying Euclid's division lemma to two numbers. Next step again by applying Euclid's division lemma. So after every step we have to mention. So without mentioning in the every step, if we write only the word algorithm, then it is sufficient. Because algorithm means steps of procedure to solve a particular sum. So here we are solving or finding a particular sum, means to finding the HCF. So that's why if we write the algorithm, word algorithm, it is sufficient. Okay. Now applying Euclid's division algorithm, we will apply algorithm to these two numbers. We have to break in the form BQ plus R. So what happens, generally 50 or 60% students, they can do it very easily. But some students may face a problem that how to find, how to break. So to overcome the problems, what we are doing, we are showing a simple process that you have to do in the rough. No need to show, you can do in the rough, or if you show then also no problem. See what we are doing, generally what we do, we divide a greater number by the smaller number. So we are dividing 396 by 231. So 231 ja 231, remainder is 165. So you see the remainder is 165, not 0. So what we have to do, we have to again divide. What we will divide? We divide the preceding or the last divisor by the remainder. So again we are dividing 231 by 165. Again we are getting remainder 66. In this way we have to continue the process till we will not get the remainder as 0. As soon as we get the 0, our division ends. Finished here. So from here we can easily now write in the form A equal to BQ plus R. How? Suppose you see 396 equal to 231 into 1 plus 165. That is our division algorithm. So 396 equal to 231 into 1 plus 165. Here you don't write 1 into 135, because our procedure is we are applying lemma to 396 and 231. So if you write 1 into 231, this 1 will become now the divisor. Okay. So what you do, keep in your mind and be alert here. So 396 equal to 231 into 1 plus 65. So 165 means it is not 0. So again we will apply lemma. So 231 equal to 165 into 1 plus 66. 231 equal to 165 into 1 plus 66. Again 165 equal to 66 into 2 plus 33. So in this way we will write. Now as soon as we got the remainder is 0, then according to the algorithm, B is the HCF, that is the divisor is the HCF. So the last divisor was 33, so HCF is equal to 33. Sometimes the students may confuse. Then what to do? Very simple, no need to confuse here. As soon as you got the remainder 0, if you confuse here, what will be the HCF? You look at the last non-zero remainder. That is the HCF. Both are same. So the last non-zero remainder is how much here? 33. So therefore the HCF is 33. Okay, clear? Now what happens if 3 numbers are given? You have to find the HCF of 3 different numbers by using Euclid's division algorithm. So what you do, first of all you take 2 numbers, any 2 numbers. Suppose here if we consider this example, if one more number is given, suppose 132. Suppose 132. Then what will be the HCF? So एकदम very simple, एकदम easy है, कुछ करना नहीं है. First 2 procedure will be the same and find the HCF of first 2 numbers, but don't write the answer. First you do as usual, find the HCF and then you write HCF of 231, 396 is equal to 33. Then again applying Euclid's division algorithm, to the number is 132 last, 132, 33. Then you apply division algorithm to these two numbers. So what will become? 132 is equal to 33 into 4 plus 0. Sometimes it may be more than 1 or 2 steps. No problem. As usual process you do. And then here you see, as soon as we get 0, our divisor, that is B, that is 33, is the HCF. So the HCF of all the three numbers will become 33. In this way, you can find the HCF of three numbers also. Okay? Very good.